This is part 2 of Piecewise Functions. We're going to do it backwards from what we did in part 1. In part 1, I gave you the function and you graphed it. This time you're going to be given the graph and you have to write the function. So the reverse of what we did in part 1. All right, so we can see we have two pieces here. We can tell that this is an open circle. The graph itself doesn't have arrows on it, so we have to kind of assume. So this here is going to be a closed circle, and then we have some arrows heading off the end of the graph that way. So with our piecewise functions, we know that we're going to have an f of x out here and a brace. And we're going to have some functions inside. Doesn't really matter which one you start with. If we take this one here on the left, we can tell that it's starting at -1 and moving to the left. So as far as our restriction goes, we know that x is going to have to be less than or equal to -1 because of the closed circle, that tells us the equal to, and that we're always going to the left of -1. All right, now we need to know its equation also. So we have the points -2, 0 and -1, 1. Now there's a variety of ways that you can find this, and we'll talk about several different ones. One thing you can do is locate the slope. So here, if you're going from -2 and you go up 1 over 1, you can tell that your slope is going to be 1. So we know that we're going to have an x. And if we do that again, even though it's not there, it would have continued. So up 1 over 1, we can tell that the y-intercept would have been 0, 2. So this equation is x plus 2. All right, let's take a look at the second equation. This one also gets its start at -1, but there's an open circle. So when we write the restriction, our domain is going to be x is greater than without an equal to -1. Now we need to figure out this equation here. So last time we used slope and y-intercept just visually on the graph. This time let's practice reviewing point slope form. Point slope form, if you remember from algebra 1, is y minus y1 equals m times x minus x1. All right, so we can fill in a point here, x1 and y1, because they gave us 2 points, and it doesn't matter which one we use. So let's just use this first one, -1, 0. So we have y minus 0 equals, we'll come back to the slope, x, it's going to be minus -1, so that'd be plus 1. All right, but we still would need a slope here. So let's see, if we count from -1, 0, down to 1, -1, we'd go down 1 to the right 2. So down 1 to the right 2 tells us that we have a slope of -1/2. We have -1/2 as our slope. The only thing we can't really tell, and the reason why point slope is better to use on this than just looking at the graph, we can't tell specifically where that's going to cross. But algebraically, we can figure it out. All right, so this side, y minus 0, is of course just y. And then we distribute the -1/2, so we have -1/2 x. And then -1/2 times 1 is -1/2. So now we can tell that our y-intercept must have been crossing at 1/2 in this negative direction, which we probably could have guessed before, but now we've verified it with point slope. All right, so that's our whole function. We're done. Okay, now this next one has 3 pieces. 1, 2, 3. So when we go to write our function, you're going to have 3 different parts that you're going to write. I would like for you to pause the video and see if you can come up with what any of those 3 are before you come back and hear me talk about it. Just like before, the graph doesn't quite have all of the necessary features. We need to have some arrows there. And also the points are here, but just so you know, this is at -2 and this one's at +2. So those points are kind of there to help you, 2, 4, and -2, 4. Sometimes it doesn't quite look like it lines up. But if you start on this left piece like we did before, it starts at -2 and heads to the left. So we could see, and if you want to use a closed circle, you can. X is less than or equal to -2. And then we've got to figure out some slopes and y-intercepts to write our equation. You can do that by counting. You can do that by your slope equation. Maybe it'd be good for us to review what that is. To find slope, we do y2 minus y1 over x2 minus x1. So you could substitute these points in to find slope that way. Or again, you could count up and over. So the slope for this line is going to be 3. If you count up and over, you get 6 over 2, which reduces to 3. And again, you can also do it this way. So you have 4 minus a -2, which is +2. And then -2 minus a -4. So we have 6 over 2, which is 3. But then we still need to find our y-intercept. So you can go back and use point slope, y minus, and you can use either one of these points. 4 equals 3 times x plus 2. And then we solve that out. 3x plus 6, add the 4, and we get 3x plus 10. So we know that that first line here on the left is 3x plus 10, and we're only going to graph it when it is less than -2. All right, now this one in the middle. We talked about horizontal lines in the first piecewise lesson. We know that that should just be a y equals a number. So in this case, y is equaling 4. So we have 4 for our equation. No x's, no variables, just 4. And we need to put a restriction on it. It's going from -2 to +2. So we have a double inequality we're going to write. So -2 is less than x is less than or equal to +2. Since we already included -2 up here, we don't need to include it on this one. And kind of a preview, when we get to this next one, we can see that it starts at 2 and it gets greater. So we can put the equal to there. We don't need an equal to on both restrictions. You only need it in one place. All right, then this last one, again, we need to find slope and the y-intercept. You can find slope either by counting or the equation. If we go down and over, we find out that our slope is -3x. And then when you solve for your y-intercept, you get +10. So that is our finished function. Has 3 different pieces. Piecewise functions can have as many pieces as they want. So we're most familiar with the 2-piece ones, but they can definitely have many, many, many pieces. All right, let's take a look at this word problem. You have a summer job that pays time and a half for overtime. That is, if you work more than 40 hours per week, your hourly wage is an extra, for the extra hours is 1.5 times your normal hourly wage of 7. Write and graph a piecewise function that gives your weekly pay P in terms of the number of hours H that you work. Okay. So first of all, instead of using f of x, we're going to be using P of H. And there's 2 different situations that we have. We have our normal wage of $7 an hour. So that equation is pretty self-explanatory. 7 times the hours that we work. And we'll get that if we work anywhere between 0 hours and 40 hours. Okay, so if you work more than 40 is when we start getting the overtime. But just regular pay is from 0 to 40. All right, so the next one says we get 1.5 times our normal wage to work overtime. So here's where we really have to think through this. Let's start with our $7, and we're going to multiply that times 1.5 to figure out what our overtime wage is. So we should get 10.5. So we're going to be making 10.5 for every hour over 40. So we know that our restriction for H has to be greater than 40. Now, since we don't want to include all the previous hours that we were paid, our 10.5 is not just times H, it's times your H minus your original 40. Let me further explain that a little bit. Let's say you worked 42 hours. You're not going to get 10.5 times 42. You're only going to get the 10.5 times those 2 extra hours you worked. Plus, you get 40 hours times 7. So you get your original pay for the first 40, and then you get your extra pay for any hours over 40. So how much would we get for our 40-hour work week? 7 times $40, that's $280. And then this part here calculates our overtime. So if we simplify this a little bit, distribute, we get 10.5 H minus, we have to take 10.5 times 40, so minus 420, plus the 280 we got for the normal 40 hours. So we can simplify all that down to an equation of 10.5 H minus 140. So we did our piecewise function here to represent our pay, and now we need to graph it. All right, so here we need to be aware of what we should put on our X and Y axis. So our X axis is hours. We need to think about how many hours we may work. We know we're going to work at least 40, and then we have the potential to work some overtime, so we need our numbers to include 40. So maybe if we had 40 kind of in the middle, you probably aren't going to work too many hours over 40, but just in case, maybe we count by tens. 10, 20, 30, 40. That will account for our normal working hours. 50, 60, 70. Hopefully no one's working that much overtime, but you would make a lot of money. All right, and then we need to figure out what our y-axis is. Our y is talking about our pay or our salary. And notice that we are labeling our x and our y axes. All right, so our salary, we need to figure out how much we could potentially be making there. So we know that if we worked all 40 hours, we'd be making $280. So that would be kind of in the middle. So maybe if we count by hundreds, 200, 300, 400, 500. And you don't necessarily have to count by those numbers, just as long as we can get a good look at what the graph would look like. So obviously if we worked 0 hours, we would get $0. 10 hours, 10 times 7, that would be $70. We can keep working that from there. We already figured out that 40 would be 280. And because this is a linear equation, those dots that we plotted should be in a straight line. So here's our first piece from 0 to 40. Remember, with closed circles on either end. And then we're starting at 40, which would be an open circle. But we talked about how closed circles supersede open. So you do not put an open circle there. So it's going to start at 280. And we have some other values that we would need to find. So let's say we worked 50 hours. We would take 10.5 times 50 and then subtract 140. So that is 385. So the point, and sometimes it helps to write down those points, 50, 385. You can write it on your graph or off to the side. What if we worked 70 hours? So 10.5 times 70 minus 140, 595. So again, this is a linear equation, but it's steeper. It's going up more than our regular because we get paid more for overtime. But unlike some of the other graphs we did, notice that they connect to each other. We had some that connected before, but some were split. This is definitely a connecting graph. It wants us to state the domain and the range. So domain is our x values, in case you forgot that. So we could work, the lowest amount would be 0 hours. And then what our highest amount that we could work in a week would probably not be feasible. But if you worked 7 days a week, 24 hours a day, it would be 168 hours. I don't think anybody would actually do that, but technically that's your domain. Range is your y values. So if you worked 0 hours, you would make $0. And if you worked 168 hours, you'd have to put that in there and calculate it. Take 10.5 times 168 minus 140. And you come up with $1,624 a week. Would be the cap that you could make. Last question, how much would you get paid if you work 45 hours? Well, that's easy to figure out. We just take our 10.5 times 45 minus 140. And we find out that we would make $332.50. So we make our $280 for the regular part of our work week, and then we have those 5 hours of overtime. So that bumps us up to $332.50.